Are you able to see the screen, you people?
Yes, sir.
Yes, sir.
All right. I ended on question 9, right?
Yeah.
Is it 9?
No, brother, but
Yeah, it was 9. All right. Okay. Like 9. Question 9. All right. So for question So for question 9, we've been told to use synthetic division to show that g of x is a factor of f of x and complete the factorization of f of x. That's the question. So we're trying to show that this guy here, g of x, is a factor of this. And then we know that the factor is something that will give us the remainder of 0. When the remainder is not 0, then that's not a factor. So for instance, our question, which is B, it's asking us to say, we prove that this g of x, which is equal to x minus 1, is a factor of this. So what you do using synthetic division is that you first equate this x minus 1 to 0. Now, when you equate this, then you say, now let's solve for x. Now, if this is equals to 0, you say x should be equals to positive 1. When the negative 1 crosses the equal sign, it becomes positive there. Now, when you have that, your job next is now to use synthetic division by getting this guy, the one, your factor. Then now you write the coefficient of the polynomial you have been given. Like in our case here, the coefficient you have 3, 19, negative 38, and negative 16. So we write them here. So I have 3, 19, negative 38, and negative 16. So now when you have this, you first drop down this guy, the 3, which the first coefficient, always drop it. Don't forget that when you're using synthetic division. When you drop this guy, you say 1 times 3, it will give you 3, isn't it? Then 3 plus 19, this is the 22 here. Then you do the same thing. 22 times 1 is the 22 there. Then you have negative 38 plus 22, it's negative 16. Then negative 16 times 1 is just negative 16. So negative 16 plus negative 16, we're having negative 32. So now the quotient is this guy. The 3, since we have now reduced the polynomial from this was power 3, isn't it? So when you start writing here, you start with power 2. Then you go to using these values you have found here. You take them the way, since here it's positive 3 plus 22 minus 16. And then you start putting here, since if this guy was x, this is x to the power 3, right? So here you start with x to the power 2 plus 22x to the power 1. So it keeps on reducing until you reach here x to the power 0, which is just negative 16. Now, this is our quotient, right? So now our remainder is this guy here, which is negative 32. Now, since x minus 1 is not a factor, you leave it like that. There's no need to factorize this thing because we have shown that this x minus 1 is not a factor. There's no need to go further with the factorization. Are we clear on this one, people? Are we all clear?
yes, sir.
Yes, sir.
Yes, sir.
Proceed. Okay. For question 9, I believe the concepts are one and the same. If you have challenges, you will let me know, because I believe this is just synthetic division. I wanted to emphasize on this guy, which is not giving us something like a factor. So for the remaining ones, they are all factors because you always have 0 here. Yes, you always have 0. I want to concentrate much to those which are down there because for this one, I believe if you have challenges, you should let me know. Then we go to question 10. Question 10 is acting as
Yeah.
Oh,
Yeah. My second day.
so
hello?
which story sheet is this one?
Stereo sheet 4. We're finishing stereo sheet 4. So that on Tuesday we just go ahead with stereo sheet 5.
All right, sir. Thank you.
Wonderful. So now for question 10, we've been told to find the values of k that makes the second polynomial a factor of the first. So now when you're finding for this type of guys, when you're finding the values of k that to make the second polynomial to be the factor of the first. So this is our second polynomial, isn't it? We know that we know that when we are finding factors, we always equate this guy, our second polynomial is equals to 0. Then we solve for x. So here x is equals to 2, right? So here this is the 2. Now, when you're solving for k, since we know that this is the we know that the polynomial that you have been given on to prove is the factor. Then we know that a factor is always equals to what? To 0. Here under there is a 0 there. So now when you substitute, when I'm trying to solve for k, where there is x here, where there's x, we'll put a 2 which is there. So now when you put a 2 and then you put a 2 and then you put a 2 in everywhere there's x, you find that your k is equals to 6. So for question 10, that's how you solve those polynomials. If you are solving for k, just keep in mind that you can always look for the factor of the same equation. Then you say the same equation is equals to 0. Then you just solve for k. So here our answer is simply 6 here. That's our k. And then for b, it's the same.
So
Yes.
is it that always you'll be given the second equation, for instance, where it is x minus 2?
Not always. Sometimes they might just give you, like, I think there's a polynomial of this type here. We'll go to, is it question 18? When we reach question 18, then I'll answer that question, sir.
All right, sir.
Wonderful. But any questions on this guy here, question 10a? Is anyone having challenges, please? Are we all clear?
Yes, sir.
Okay, so we proceed. When you look at B, we've been told that to find the values of K, it's the same idea, whereby we first solve for the second polynomial, we find the values of X, isn't it? So we find that X is 1. Now, when we have 1 there, we now substitute in our original equation, which is k squared x to the power 4 plus 3k, this whole thing, we put a 1 where there's x now. So we have k squared, there's 1 there. When we do the manipulation, we form a quadratic equation. So you know that each time you're dealing with quadratic equation, you should always keep in mind that there are always 2 possible solution or roots that you get from a quadratic equation. So when you do the manipulation here, k squared plus 3k minus 4, you know that the sum is 3 and the product is negative 4. When you find those 2 factors, you find that k is equals to negative 4 or k is equals to 1. That is our values for k. Are we all okay?
Repeat the slide a little bit, sir, from the top.
Okay.
Back a bit. Yeah, I'm not. Just go back a bit, sir.
I go back to question. This is where B starts from.
Okay.
You have seen, Why are you not clear?
So
Hello?
you start from
Just
A.
from there, sir. Just start from there.
Okay, so we've been given this polynomial, isn't it? You have your theory sheet, right? Theory sheet 4. So we've been given this polynomial and another polynomial, which is just a linear polynomial because it is raised to the power 1. So we have these two polynomials, isn't it? Now they're saying that find the values of k that makes the second polynomial a factor of the first, isn't it? So you know that this is the first polynomial, isn't it? And then you want to find the values of k that will make the second polynomial factor of the first. So we know that we have been given this polynomial here, isn't it? So we know that when we equate this guy to 0, we solve for x, right? Since when we're finding factors, always keep in mind that a factor is something that will give you a 0 when you substitute. Let's say if you have this polynomial here, when you put, let's say, k and x, this whole thing should always be equals to 0. Let's say if you have a polynomial, let's just imagine of any polynomial, then you know that p of negative b over 2a is always equals to 0. I think that's the formula for polynomials. So when you have that, you say x minus 1 is equals to 0. Then you solve for x. You know that x is 1. Now, where there's x here in this polynomial, you put a 1. So here where there's x to the power 4, we put a 1. Then where there's x to the power 2, we put a 1. You discover that 1 to the power 4 is just 1. 1 times k squared, it will be k squared plus 3k times 1 is just 3k minus the 4 here. So I've now discovered that this polynomial is now a quadratic. It's now a quadratic. And then you know that when we're dealing with quadratic equations, we should always keep in mind that the quadratic equation always gives us 2 possible solutions. So for this one, you can either use the quadratic formula or the completing the square method, or you can even use the one I'm talking about, this type of factorization here, where you find your sum and product. So whichever you may find comfortable with, please do use it. And keep in mind that for this one, it is not always that it works, but for completing the square and the quadratic, those are always working for all types of quadratic functions. And then when you have your sum and the product, these two factors, you have negative 1 and 4, isn't it? So here, you just use that simple method. Since you have negative 1, you can easily say, okay, that will be k squared minus k. You factor out the k, which is common, right? Plus here you have 4k minus 4, isn't it? So 4 is common here. You factor out the 4. So you remain with k plus 4 and k minus 1. Then you solve for k. K is equals to negative 4 or k is equals to 1. Are we now clear?
Yes, sir.
Okay. We do more examples on question 10 or we proceed to 11. I believe for solving, I'll send the solutions. Don't worry. We proceed.
Yes, sir.
Wonderful. We go to question 11.
So where will you send the solutions?
I'll send to your class. They managed to give you the previous ones. The part A, is it part A? You have
Yes,
them.
sir.
No, we don't have them.
We have it.
Sir, how come you don't have it?
From my teacher, I didn't get any.
This is TG1.
8.
Hey. I'll talk to Mr. Joshua. So I believe he sent. So, all right.
All right, I'll confirm.
All right. Thank you. Okay. So for question 11, it's trying to tell us that if you know that negative 2 is a 0 of this function, we know that negative 2 is a 0 of this function. Explain how to solve the equation x to the power 3. This equation, how do we solve this? If you know that negative 2 is a 0 of this same function, how do we solve that? So if we know that negative 2 is a 0, isn't it? So which means that we can write negative 2 in form of x plus 2 is equal to 0. That's how you start your explanation. I don't know if you have a better way, please use it, but always keep in mind that you should use, probably should show something like x plus 2 is equals to 0. Then you say that implies that x plus 2 is a factor, and you can use the wrong division or synthetic division to solve this polynomial. Are we okay with the explanation, please?
How is negative 2 0? And where is negative 2 in the equation, sir?
If you read question 11, it's telling us that if you know that negative 2 is a 0, so you know that negative 2 is a 0, isn't it? Yes, so since you know that negative 2 is 0, right? So we were talking about factors, and then you know that the factor, let's say I've been given a polynomial, isn't it? So whatever you put in that polynomial, if it gives you a 0, then you know that that thing is a factor, right? So since we know that negative 2 here is giving us a 0, isn't it? So you know that negative 2 is a factor of this polynomial. Now, since we know that negative 2 is a factor of this polynomial, since here we assume that x is equals to negative 2, isn't it? Since here, when we are solving these guys, remember this part here, where we are substituting x is equals to 1. It's the same concept here. Now, for this one, they have been given that x is equals to negative 2. So when the negative 2 comes to the left-hand side, it becomes x plus 2 is equals to 0, which can be written in this form, in the factor form of x plus 2 as our linear polynomial.
Since we have
Are we okay?
Now, sir, does it mean that x plus 2 is equals to 0 is the final answer?
No, we're explaining here. The question is saying, if you know that negative 2 is a 0, right? Of function, of this function, open your Taylor sheet, you go through it. Of this function, x to the power 3 plus 7, this function on top here. If you know that negative 2 is a 0, explain how to solve the equation. How do you solve this equation if you know that negative 2 is a 0? You're just explaining here. We're not solving, isn't it?
Yes, sir.
Yeah, so now how do you explain this process? Just a minute. There's this process here on top. Suppose you were to just explain how to find the values of k. How do you go about it? So you start by saying that I've been given this guy here, right? So you say x is equals to 2. Then you're explaining, since we know that x minus 2 is a factor, we simply say, okay, where there's x, put the 2. Okay. So now, where there's x here, we'll put 2, isn't it? In order for us to solve for k. So when you do that, your k will always come out. Say that you'll be quadratic or something which is just straightforward. Your k will always be given. Now, here on question 11, here we are showing, right, how to solve for the value of k. Now, here they're just asking us to explain on how we can solve this polynomial if we know that negative 2 is a 0. So you're just explaining on how you can solve it yourself. How can you solve it? So since we know that negative 2 is a 0, we can simply say that if negative 2 is a 0, x plus 2 here will be the factor. And when you have your factor, you can either use what? Long division or synthetic division to solve the polynomial. Are we now together, people? Are we okay?
Very much
Yes,
okay,
sir.
sir.
Wonderful. Let's proceed. Yeah.
Sir, will make that.
We go to question.
sir.
Yes.
So in short, you are saying the question, right?
Huh?
So in short, you are saying this negative 2 is included in the question.
Yes, negative 2 is still in the question. So question 11.
All right, the problem is I don't have
Okay, I'll send the solution, sir. So when you have the zero sheet, try to compare now. If you have challenges, please get back to me.
All right, sir.
All right.
Sir, this is situation sheet what?
Zero sheet 4, zero sheet 5 will start on Tuesday.
Okay.
All right. Okay, we go to
So.
question.
So
Go ahead, please.
yeah, on x, do we replace a -2 or x plus 2?
On x,
Yes.
so you know that x is equal to -2, so we replace -2, right? Here. Now here we're not solving for k.
Yes.
Yeah, here they're asking us, so now we can solve this for the polynomial, the whole polynomial here. If we know that x is equal to -2. Since x is equal to -2, we can, bring the -2 to the left-hand side and have x plus 2, isn't it?
Yes.
Which is equal to 0. So x plus 2, you can write it in this form, x plus 2, which is just in form of a factor, right? So you can use long division while you say x plus 2, you do that, let me show you, just a minute. Okay. So you have something like this. You have x plus 2. Don't mind my handwriting. Then here now, you should have something like this.
Jesus Christ.
Yeah, you have seen it.
Yes.
Yeah, so that's why you put the whole polynomial, then the x plus 2 to be in this form now. So you can either use this method or the synthetic division to solve this equation. Hope you are now clear, sir.
Yes, we can move on.
Okay. We got to question 12. Okay, for question 12, the question is find k so that 4x plus 3 is a factor of this polynomial here. Then we know that when you're dealing with factors, always equate this guy we have been given to be equal to 0.
So negative over 4. So
Yeah, so if you have been given this type of polynomial, right? So we know that 4x plus 3 should always be equal to 0. So now, if you know that 4x plus 3 should always be equal to 0, you have to solve for x now. So when you do that, you find that x is equal to -3 over 4. But what's our question? Our question is saying that find the value of k. Since you know that x is equal to -3 over 4, where there's x, we'll put -3 over 4. Then when you do that, everywhere where there's x, you put -3 over 4, then you equate it is equals to 0. Then you find that -3 over 4 to the power 3 is just -27 over 64 plus 23. Then this is the same as 9 over 16 minus 10. This is just -3 over 4 plus k is equals to 0. So when you do those simple addition and subtraction there, you find that you have something like this down here. Negative, when you multiply throughout by 16 here, you have -135 plus 207 plus 120 plus 16k is equals to 0. Then keep in mind that we're solving for k, right? So when you add -35 plus 207 plus 120, you're having 192, which is there. Then here you take this guy, this positive 16k, to the right-hand side, you have -16k. When you divide both sides by -16k, you discover that your k is equals to -12. Then you are done with question 12, then you get your full marks by showing this. Are we all clear? Are we all clear, people?
Yes, sir.
Yes, sir.
But so I've got a question.
Okay.
Sir,
Yes.
but on the first question, when you cube root -3/4, is it
Just a minute. Okay. Yes, carry on, sir, please.
yeah, I was asking that on the first part where
Okay.
it is what 20 in the
This part.
brackets it's -3/4. When you cube root, yeah, on this, yeah, on that same part, when you cube root the 4 is, oh yeah, okay.
You have seen it, eh?
Yes, sir. Yes, sir.
We proceed. Is everyone
Yeah,
clear?
sure thing. Yeah.
So I have a question.
Okay, go ahead, please.
There, did you multiply 5 times -27 to get the figures that are down? Just try to scroll down.
Yeah, 5 times
Yes.
-27, yes. So for you guys, since there's no calculator, you know what to do is 5 times 7 is what? 35, right?
Yes.
Now you say 5, remember what? 3, right? 5 times 2, it's 10, right? Plus that 3, it's 18. So you have -135 there.
Okay, sir. Thank you.
Welcome. We proceed.
No, sir, just a minute. I also have a
Yes.
question.
Okay.
Just backslide
Wait,
a
sir.
bit.
I scroll up.
Yeah.
Yes, go ahead, Mr. Arik.
I've seen the thing I didn't understand.
We can proceed.
Sir,
Yes.
Yes, sir.
I've not seen the use of this 4x plus 3.
4x plus this one.
Yes.
This one is what you are solving for x. You equate this guy to 0, then you find that x here is -3/4. That's the use of this guy here.
The value of x.
Yes, sir, you have to play around with this guy. Yeah, so when you're given this guy, play around with it a bit. You find that x is equals to -3/4. Then we have used this part here. Are we okay, sir?
Aye.
Yes, sir.
Oh, wonderful. We proceed now. We go to question 13.
Yes, sir.
So
So for question 13, there was an error to the question. So if you try to solve it whichever way you want, you find that you can't factorize that thing because you won't have let's say you won't find the zeros of that polynomial, the 2x to the power 3 there. So for question 15, it was an error. It was supposed to be 2 x to the power 2. Are we okay? Hello?
Yes, sir.
Wonderful. So we go to question 14. Now, question 14 is telling us find the quotient of x to the power 3n plus 1 and x to the power n plus 1. So we're finding the quotient, right? Then using the wrong division. So you know that for this one, you can't use synthetic division. Although you can use it, yeah, in fact, you can use it. It's straightforward. Since the power of x is 1. But long division is much easier when you're dealing with these powers of n, so that you won't get confused. When you are using long division, you can say now, you put them in this form now. Since we've been given that x to the power 3n plus 1, isn't it? So here we have x to the power 3n. We know that here it will be plus 0, x to the power 2 to the power n, plus 0, x to the power n plus 1. Are we okay there? Now to write this guy.
Yes.
No, sir. Because I'm on.
All right, so we have been given something like this. We have
Time. Since someone did some.
so we have been given that x, x to the power, this is 3n plus 1, isn't it? That's what our question is telling us. Now here you have noticed that the power here is 3, isn't it? So you know that when you have the power 3, which means here you should have something like x, when you're using long division, always keep in mind that when probably you have the power 3 there, isn't it? So there, let's use this one, which you're able to see properly better, right? So now, if you want to use long division on this type of equation, you have been given this, forget about the n for now. The first thing that you do is you say x to the power 3, right? Plus, if you're using long division or synthetic division, show that here there is a 0, isn't it? 0, x, this is x, right? The power 2 plus 0, x, plus 1. Are we okay on how to get this guy here, madam?
No, sir.
Huh?
Okay, let's do this. You know that we have x to the power 3 here, isn't it?
Yes, sir.
So we know that plus when you are using long division or synthetic, keep in mind that here there is a 0, isn't it? What is 0 times x to the power 2? Hello?
It's 0.
Yeah, it's 0, right? So since you know that this thing here, we're just trying to use it so that it is easy for us to work out these values which are here. Because without these guys, we'll make some errors. So we just write the 0 there, x squared, because here our function is still this guy here. Now, when we show that here there's the coefficient of x squared here, which is, we cannot see it, it's 0, and the coefficient of x, it's 0, isn't it? So we haven't changed anything here. We're just showing that the coefficient of x squared here is 0, unless it was not in our original equation, but it's there. It was not in our original equation, but it's there. Are we getting there, madam? Are we getting there?
Yes, sir.
Okay. So since you know that x squared is here, but the coefficient of x squared is 0, just like the coefficient of x here is 0. It's the same concept here. Yeah, it's the same concept which is here, where we have x to the power n plus 1 is equals to, we know that x to the power 3n is the same as plus 0 x, we reduce the 3 here by 1, right? So try to subtract minus n here. So when you subtract minus n, you find that you have 2n. 2n minus n again, you have n here. With n minus n, you are getting the 1 which is here, because anything less to the power 1, anything less to the power 0, it's 1. So try to subtract n to everything on top. You find that 0, x to the power 2n when you reduce the power by n, right? Reduce the power by n again, you find that it will be 0x to the power n plus 1. Then you now start doing the long division. Okay, so when you have this guy here, you know that your next job is just to start dividing x to the power n into x 3 to the power n. It goes there, 3x to the power 2n. So when you know that x to the power 2n is the times this guy goes into that one, you just say x to the power 2n times the same thing. You're getting x to the power 3n, since you know that when you're multiplying indices or indices of the same base or index, you always add the powers. So since when you multiply this guy and that guy, you add the powers, you get 3n, right? And then you do the same. X to the power 2n times 1, you get x to the power 2n. So you have seen now the importance of this 0 times x to the power 2n coefficient. It will be easy for us to do the addition here. So now when you subtract this guy, this thing will go to 0. Then you subtract this guy here, you get negative x to the power 2n. Now when you have this guy, you divide again. So you say x to the power n divided by negative x to the power 2n, you get negative x to the power n. Negative x to the power n times x to the power n, we're getting negative x to the power 2n. Then negative x to the power n times positive 1, we're getting minus x to the power n. We drop down this guy, the x to the power n, with a 0 coefficient, right? No wonder we are showing that there's a 0 coefficient, that's so that it's easy to do the manipulation here. So when you drop down this guy, you now subtract, isn't it, everything. This guy here to give you a 0 and you subtract, but this guy to give you a positive x to the power n. Now, if you have here 0 times x to the power n minus open, there's a negative here, isn't it? So negative becomes positive, right? So that's why we're getting the x to the power n. So now x to the power n into x to the power n, it goes there one time. So 1 times x to the power n, we're having x to the power n here. Then when you find that you have x to the power n here, you say again 1 times 1 is the one which is here. You subtract. So you have noticed that this guy will give us a 0 and that guy will give us a 0. So you know that our remainder here is 0 and the quotient is x to the power 2n minus x to the power n plus 1. This one on top here, that will be our quotient. That's how you solve that question. Then you get your full marks. Are we all clear?
No, sir. Can you kindly repeat your thing?
Okay.
Oh my God.
Right. Okay, so like I said earlier, in our question, we've been told to find the quotient, right? X to the power 3n Okay, we've been told to find the quotient of x to the power 3n plus 1 and x to the power n plus 1. So you know that x to the power n plus 1 here will be our you can even call it our factor, right? So we're trying to use the wrong division. Since we know that this guy is our factor, isn't it? So we can easily use wrong division. Yeah, I've just remembered that wrong division is much easier If you are comfortable with the synthetic one, please use it. Yeah. So we know that this guy we're dividing into x to the power 3n. Try to ignore this part for now, plus 1, isn't it? But keep in mind that there is also x to the power 2n here, but the coefficient is 0. None that's not appearing in our equation or in our question. But always keep in mind that you have to be showing these zeros each time you're dealing with polynomials, because these zeros will help you get the correct answer. Because if you're not showing, you'll be having challenges, and now you're going to go about the same question, manipulating the question. So when you know that this is the same as you have 0 times x to the power 2n plus 0 times x to the power 2n plus 1. So now what your next job is, since you have arranged them properly or in order, in probably this is in descending powers, right? So we have 3 to the power n. So we reduce this guy by n, right? So we have 2 to the power n. We reduce this guy, you have something like this is the 3, 3n, isn't it? This is the power. So this power will be reducing by n. So when you do this guy here, you find that it will give you 2 to the power n. So this 2 to the power n is the one we are having here. This is the 0 times x to the power 2n. So we have noticed that these powers are reducing by n each time. So when you do the same here, you take the 2 to x to the power 2n minus n, you have x to the power n. So when you do n minus n, okay, let me just finish. I'll allow you to ask. Yeah. So here, when you do this, we have 3n minus n is equals to 2n. So this x to the power 3n, it always reduced by n. So when it's reduced by n, you have discovered that x to the power 2n is not there, which means that the coefficient for this guy is 0 here, which is there. Plus, when you reduce this power by n, it is x to the power n. So you have noticed that the x to the power n is not in our original equation, which simply tells you that the coefficient is 0 again. Plus x to the power n minus n, it's 1. The 1 is there in our original equation. So we leave it like that. So when you have this guy here, you start dividing. You have x to the power n into this guy. It will give you this one on top. Use the same principles, you know, when you're dividing polynomials. X to the power n into this guy. This guy, it's simple. You can even use whereby when you're dividing, these powers will reduce by 1, right? So it will be, since they have the same base, so this power is reduced by 1. This is the 2n here. So now x to the power 2n times that thing there, it simply tells you that when you're adding these same numbers or same bases, you add the powers. Since we're multiplying, we add the powers. That's why we're getting the 3 to the power n. Then you just do the same. X to the power 2n times 1, it is plus x to the power 2n. When you subtract now, you find that this thing here to go away to be 0. Then here you have negative x to the power 2n. You divide again using the same principles in long division. You discover that this thing will reduce to just 0. Yes, Mr. Karis, go ahead, please.
So
Yes, go ahead.
can you like the last question?
Okay, which one, sir? Hello? Yes, go ahead, please. We proceed.
Yes, sir.
Yes.
Okay, wonderful. You go through the solutions. If you are still have challenges, please get back to me.
So
Yes, sir.
me, I'm not clear on the where you subtract 0x minus x to n. How is it negative 2? How is it negative x to n?
Yes, sir. When you're subtracting this.
Yes. Isn't that supposed to be 0?
Oh, sir. Okay, let's do this.
It's 0 times.
What is 0 times x to the power 2n, sir?
Sorry?
0.
0 times x to the power 2n.
It's 0.
Yeah, so here we have a 0, right? Here there's a 0. 0 minus x to the power 2n. What are you getting?
Oh.
You have seen it.
Okay, I've seen it.
Sir.
Yes. Hello?
Sir.
And
Oh, I'm lost here when you're dividing x to the power n into 0 x to the power 2n. How are you getting x to the power n?
this, we are dividing this guy with this base part. Yeah, we're not reaching this part here. We are using this
Okay.
part when you're multiplying now.
Kindly explain to me how you go forward from after we subtract x to the power 3n minus x to the power 3n from here.
So, okay, let's say you are here, right? You have negative x to the power 2n. You know that you're okay with this part, right? Yeah.
No. I'm a bit behind here. How you got to this part from where we subtracted x to the power 3n minus x to the power 3n here. This is what I'm
0, right? So what
I
is
am.
0? Yeah,
Yes.
we are okay. We know that this guy times that guy is this guy here, right? Oh, this guy here times the one here, isn't it? Yeah, so when
Yes.
you're subtracting, what is 0 minus x to the power 2n, sir?
It's negative x to the power 2n.
Yeah, it's the one here, down here now. You have seen it, eh?
Oh, yeah.
Then
So
you
in
divide.
short, what you're trying to say is that when we get a 0, when we subtract x to the power 3n minus x to the power 3n, it's 0.
We
So
don't show it.
we multiply this x to the power 2n on top by the 1.
Okay. So, but you know that for this order, you're okay, right? Sir?
Yes, I'm okay here.
So when you subtract this guy, you get this one, isn't it? So when you have this guy here, your next job is you get this one here on front. You say x to the power 2n into this guy here. It will give you minus x to the power n when you do those indices. Then you take this guy, you multiply it with the same thing here. It will give you negative x to the power 2n. Then you take the same thing, you multiply it by 1, it will be minus x to the power n. You drop down the 0 so that it's easy for you to do the manipulations here. Yeah, so when you do that, you subtract. This thing will give you a 0. And when you do this, this will give you a positive 4. I'll give you time, sir, to run it through on your own. And then if you have challenges, please get back to me.
Right. Thanks.
Thank you, sir. Yeah, let us try to finish this one today. So for question 14, but it's saying in problem 15 to 17, list all possible rational roots. So I want to find all possible rational root for this equation we have been given here, which is which is on question 15. We have x to the power 3 minus 2x squared minus 11x plus 12 is equals to 0. So now listing all possible rational roots. You know that there's what we call the rational zero theorem. I believe you have heard of it by now. Why you know that you get P. P is this guy here, the constant term. So you find the factors of the constant term. So you discover that the factors of a constant term, you have 1, 2, 3, 4, 6, and 12. Since you know that these are the factors of the constant term, you go to this first part here. What is the coefficient of the polynomial with the highest power? So you know that x to the power 3, this is the highest power in this polynomial, right? So you know that it's a third degree polynomial. So since we know that, what is the coefficient for this guy? The coefficient for this guy is just 1. So this is the one down here, which is 1. So now, when you know the factors, these two things here, since 1, what's the factor of 1? We can just say it's the same thing, 1. So you just put plus or minus to everything. So here you have managed to reach all possible rational roots, but when you just define it, it will give you the same thing here, which means you have reached all possible rational roots of this function here. Are we together?
Sir,
Yes, sir.
sir, kindly repeat, please.
All right. I'm saying that when you have been taught to list all possible rational roots, right? Your first thing is you know that possible rational root is equals to P over Q, isn't it? Where P is just the constant of your function, isn't it? Here is the constant in this polynomial, like it's constant, like this 12 here is our P, and our Q is always the coefficient of the highest power. So here we have x to the power 3. If this was 2 here, we could have had factors of 2. It would have been 1 and 2, isn't it? But here the coefficient is 1, right? So we say if this is our Q here, where there is 1, the coefficient here it's 1, right? So we say Q is 1. Then you just introduce plus or minus in front of this same 1. Then now the factors of 12 here, which is our constant term in this polynomial, it's simple. We have 1 as 1 is a factor of 12, 2 is a factor of 12, 3 is a factor of 12, 4, 6, and 12. Huh? These are all factors of 12, isn't it? Then you just divide these two, then you get your rational roots, isn't it? That's what the rational zero theorem states. If you still having challenges, you can still get back to me.
Just a minute.
Yes. Sir.
What if the coefficient of x, where the value of q, the coefficient of x to the power 3, for instance, is 10? Then how can you resolve the situation?
If the coefficient is 10, sir, then your job is easy. So we have this type here, isn't it? We have 10 x to the power 3, isn't it? So this is the coefficient, right? So you know that this is our what? Our q, isn't it? Now, what are the factors of 10 is?
1.
We have 1, right? And what?
2.
2. And what?
5.
And what?
And 10.
And 10, right? So this would be on the denominator, right? So here you just put what? Plus or minus? Right?
Yes.
Plus or minus to everything. Are we okay now to find the when you do this, don't forget to divide here, down here, because you'll be dividing with something on top. Are we okay?
No. Then what's the final?
Listen, when here for instance, our coefficient, like here, our coefficient here, it's what, sir?
1.
1. So there's a 1 down there, isn't it? This is our q. You know that the coefficient for this guy here is the one which should always be down here, the denominator. So now, what are the factors of this 12 here?
Didn't get anything, sir.
Mr. Alexander.
4 and 6.
Listen, Mr. Alexander, sir. We are listing all possible rational roots. So we know the formula is P over Q. Now, what is P? P are the factors of this constant term in your polynomial. Here, the constant
I'm really
term
lost. Sorry, sir.
Huh?
I'm really lost. I didn't understand anything, sir.
So you didn't cover this in class.
No, I didn't, sir.
I believe this should be all covered, sir. Okay, let's learn it again. So your job here, sir, when you are listing all possible rational roots, Mr. Alexander, concentrate on this guy here, the constant, and the coefficient of this guy here with the highest power, right? So here 3 is the highest, isn't it? What's the coefficient of
Sure.
this guy? It's 1, isn't it?
Yes, it's 1, sir.
Yeah. So now, since you know that it's P over Q now, P is just the factors of this guy here, the constant term. What are the factors of 12? Factors of 12 are 1, 2, 3, up to 12 itself, right? Then you introduce the plus or minus, plus or minus, plus or minus up to 12. Divide by plus or minus 1. So now, plus or minus 1 into plus or minus 1, what are you getting? Like when you divide these two, you still get the same thing here. Are we okay?
Sure, sir.
Yeah, it's the same thing like you have 1
Yes,
divided
sir.
by everything here, you still get the same thing there. We proceed. Yeah?
Yes, sir.
Yes, we proceed.
So this is your final answer. That's how you find these two possible rational roots. Now, our next question is telling us that use synthetic division to test now the possible roots to find the actual root. So now here, since these are the possible,
Sorry, sir, before you.
yes, go on, please.
Yes, sir, I'm saying, how do you now use the same rational zeros to turn a given function into a linear factor?
Into a linear factor. So here you know that that's
Yes.
why I'm going to part B, so I think part B will be easier to explain.
Okay.
Wonderful. So now, since we'll find that these guys here up to 12 are all possible rational roots. So what they're telling you here is that this whole thing here, they can always give you what? A 0. It means that when you substitute something, like when you pick any name, like if you pick 1 here, we're trying to test if these are actual roots to say this will give us a factor. But when you substitute the polynomial, it equals to 0. So now, using the synthetic division to test the possible roots, we can start with positive 1 here. So when you get positive 1 from this guy, we have x is equals to 1, isn't it? So now, using synthetic division, you know that yes, using synthetic division now, you know that if you pick our first root to be positive 1 here, you can even pick negative 1, you can pick positive 2, negative 2, you can pick positive 3 or negative 3, and so on and so forth. So here we have picked our possible roots to be positive 1, right? So we say x is equals to 1. So that should be our first root. We're trying to test if this guy are actual rational roots. So now when we pick 1 here, we discover that using the same equation here, the coefficient here, it's 1 is negative 2, negative 11, and positive 12. We put them here in our synthetic division. We have them there. You drop down the 1, you say 1 times 1, it's 1, right? 1 plus negative 2, it's negative 1. 1 times negative 1 is just negative 1. You add this, you get negative 12. 1 times negative 12 is negative 12. You add this, you get a 0. So the quotient is x squared minus x minus 12, which when you factorize this thing, because the question is saying that, which is part C, is saying that use the quotient from part B to find the remaining roots and solve the equation. So if we want to find the remaining roots, since we know that x is equals to 1, right? If we want to find the remaining roots now, since we have discovered that here it's giving us a 0, which means that x minus 1 is a factor. So x minus 1 here is the factor. When we solve this guy quadratically, isn't it? Because we have x squared there minus x minus 12, isn't it? I hope we're all okay now to get the quotient. So when you factorize this guy here, you have that x minus 3 open close x minus 4. When you use the factorization method, you know to factorize this guy, you find the sum and product. Okay. Go ahead,
Sir,
please. Yes.
our normal polynomial had x power 3. Where has it gone?
This guy here, right? Well, we are talking about this guy here, isn't it?
Yes.
Yeah. So now when you know the goal of us finding list all possible rational roots is to help us to find the factor of this polynomial so that we reduce it. But trying to factorize it. Yeah. So if we're trying to factorize this guy, when you list all possible rational roots here, you discover that these are the rational roots. So if you are picking which one could be your factor, you start testing all these guys here. You pick one, for instance. Now, in our case here, one works for us, so we can't pick any other. We can just pick the same one to find the other roots, isn't it? This one here works using synthetic division. Our remainder here was 0, right? So you know that when this one goes that side, it will be x minus 1. So here we have x minus 1. So now here we have 1, right? So we know that using synthetic. So here we have x squared. Since our polynomial was the power 3, right? So it will start reducing on here now. It will be x squared minus x minus 12, isn't it?
Yes.
So this is where this guy is coming from. Are we okay now?
So when you multiply this x minus 1 by this other polynomial to give you the polynomial on top there.
Yes, it will give you this guy on top here. You can even try it.
All right, thank you.
Wonderful. So this is how you go about solving for question 15, 16, and 17. You do the same. Huh? Are we okay? Any questions?
Sir,
yes.
So repeat on the last part.
This last part?
Like, yes, yeah.
So when you reach here now, you just factorize. So that what's the sum? Yes, -1, isn't it? Then
yes,
the product is -12, right? So now,
yeah, yes.
You have remembered. So you just now do those two factors. When you add, you give you -1. You multiply, you get -12. So you know that.
Okay.
Yeah, you have gotten it. Wonderful.
Yes, sir. Thank you.
That will be your part. Yes, please.
Okay.
Sir, what happens after you factorize and the quotient? You're not able to factorize it.
So let's assume, sir, that here is x to the power 3, isn't it?
No, it's a quadratic, but having no real roots. What are you going to do in that case?
In short, they're giving you complex roots.
Yes. Then the question is telling you to solve the equation after that.
Okay, for that one, I think for those type of questions, they're only found in theory sheets, mostly just for to try your mind on how you apply the concept. But in actual exam, the questions which they bring, they normally solve them first. They even test them to say these are actual rational roots. But for tutorials, they bring questions. Normally, most of them, they don't really solve them. Yeah, so you find that they're just trying to see how you are thinking as a student in terms of applying the knowledge. Have I answered your question? So when you have given probably a complex root, which means you can just use the same method that you know, but you should find you can even use quadratic. When you find those roots, you put them in this form, then you get your correct answer.
All right, sir. Thank you very much.
You're welcome. You proceed.
Sir, there isn't the answer supposed to be x plus 3 instead of x minus 3 as one of the roots.
one of the roots. So now, what are the factors of this equation?
It's supposed to be 3 and negative 4.
So 3 and negative 4, right?
Yes.
Yeah, so we have 3x squared, which is plus 3, isn't it?
Yes.
Okay. So we have x squared plus 3x. Then we also have negative 4x minus 12, isn't it? Okay, we factor out the negative 4, get x plus 3. Oh, I guess you're right, sir. Here it's supposed to be positive.
Answers on what?
Okay. Sorry, people. My phone went off. Huh? Yeah, I was using it for, internet. So I'll just use the Murungush Wi-Fi. I hope it will be cool. Yeah, so here, sir, I think you are correct. There was something like it was a typo error. I'll change it before I send. It's supposed to be x plus 3.
Okay, sir.
Yeah, thank you.
So I'm having a question.
Yes, please.
Yes, the part where you use synthetic division.
Okay.
We found the factors. Yes. So we found
1
plus or minus 1. So no, on top.
Yes,
Yes, sir. The
okay.
possible rational roots.
Yes.
Yeah, the first one we found plus or minus 1.
Yeah.
So since you said that if you substitute, we use synthetic division, we use 1.
Yes.
We are going to get 0 as our remainder.
For this,
so is it possible that if you use a negative number, for instance, negative 1?
Yes, go on.
Sir?
Carry on, sir.
For example, use negative 1 to test the possible roots. Is it going to give us a 0?
That's why you
negative
have to
1.
test them individually, sir. So for me, I tested positive 1, and then it gave me that this guy was a 0. So you have to test everything. If negative 1 is giving you a 0, then it's an actual rational root, sir.
So if it doesn't give you, then it's not supposed to be plus or minus negative 1.
Yeah, it's not supposed to be considered as an actual root since it's not giving you a 0 here. But in my case here, I picked 1 since it was plus or minus 1, right? Then we got that this guy is 0.
Yes,
so we know that x is equals to 1 is simply a factor, right? So we can use synthetic now to manipulate this. Oh, we use synthetic, sorry, to get to prove that x is equals to 1 is a factor. So if we know that part, we can now simplify this guy. If x minus 1 is a factor, right? We can just reduce the way we have reduced this polynomial using synthetic. Put it back there. We find the 2 other factors.
Yes, sir.
All right.
So when listing, my question now, when listing, is it a must that you're supposed to put plus or minus or?
Yes,
or what?
It's a must.
Because you've said it's possible. Yes, sir. Now you said it's possible for some not to give you a 0 as a remainder.
Yeah, it's
then
possible.
Why is it a must to put a plus or minus?
Because according to rational zero theorem, you have to do this in order for you to get the rational zero theorem. But to get the actual roots, you have to test this thing. So now, if you start assuming to say positive 1 is an actual root, then what if it's not? Then you have to use negative 1. You get, so these guys, they will guide you instead of you trying to use trial and error to find the actual roots. Rational zero theorem makes it easy to say you can only use numbers. These numbers which are on top to test if they are actual roots of the polynomial. Are we okay, sir?
Thank you, sir.
Right. We proceed.
Yes, sir. Yes, sir.
Proceed to question.
Sir.
Yes.
Thank you, sir.
Yeah.
Sir.
Yes, please go ahead.
Sir.
Yes.
Never. No, no. It's a
Go ahead.
central lesson.
Hello, we proceed.
Yes, sir. Let's proceed.
Yes, we can proceed, sir.
We go to question 18 now, where we have not been given any factors. Here we don't have a factor, we've just been given this polynomial. And then question 18 is telling us that factorize the following expression. Now, how do you go about factorizing this guy here? So since now you have learned about the rational zero theorem, so you should always keep in mind that you can use the rational zero theorem, first of all, to find the possible rational roots. Now, using the rational zero theorem, we know that here the constant, our p, is 6, right? So we say p is equal to, what are the factors of 6? There's 1, 2, 3, and 6. So we put a plus or minus sign to everything. Then what is the coefficient of this guy here? 1. So we put plus or minus 1 here. When we divide this, our possible rational roots will give us this guy here. This will be our guy here. So now when these are our possible rational roots. So when we try to test for 1 using synthetic division, here again, 1 is giving us that this is truly, 1 is truly the factor of this polynomial, which is on top here. So since we know that positive 1 works, there's no need to test everything now, since we can just use the same one to solve for the other roots. So we can now do this. Since we have used synthetic here now, since x is equal to 1, we have done with the synthetic here. We have this quadratic equation. So it will be x minus 1 when the 1 comes this side, times the same quadratic equation we have found here. Then we factorize this guy again. When we factorize it, you have x plus 2 open x minus 3. That's how you go about solving this guy, which you have not been given a factor at the end. Are we all together there?
Sir, I've got a question.
Yes, Madam Monica.
Sir.
Yes.
So I'm kindly asking if you can like give an illustration where when the first when x power 3 has a coefficient, let's say 2, how do you divide those coefficients? How do you divide the factors for those coefficients with the factors of the 6?
Okay, so here you have something like this. So here probably let's use the same p on top, right? P is equals to probably plus or minus 1. Then we have plus or minus there, isn't it? Plus or minus 2, isn't it? Then here we have plus or minus 3. And then now, if this guy, you know that the coefficient of this guy, let's just assume it's 2, right? So for this guy, we have something like plus or minus 1, right? Then we have plus yes. Minus what? 2, isn't it? Isn't it? 2. Okay, there. So now when you have this type of thing here,
yes,
start with this part here, isn't it? So you say this guy, our first part here, our rational root should be plus or minus 1, because this 1 into everything is just.
So I have a question.
Hold on, sir, please. Just a minute. So plus or minus.
Question.
Then plus or minus 3. Then you go to 2 now. 2 and that to give you plus or minus 1 over 2. You have gotten the concept.
So I have a question.
That's what done, sir. Have you gotten the concept now? You have gotten it? Huh?
Yes, yes.
Wonderful. Yes, go on.
You. Wonderful.
Now, sir, on the rationals of when we find the roots, why is it that we've only put plus or negative 1, plus or negative 2, plus or negative 3, and neglecting plus or negative 6?
Okay, so sir, that's what I was saying here. That if you want, you can start with 6. Now, if you start with 6, I believe your figures will be much big, isn't it? So if you start with the smallest one, it will be easy for you to
plus or negative 6.
Hello, can you get me, sir?
Yes, I'm able to get you.
Yeah, so now, sir, let's say we pick plus or minus 6, isn't it? Now, here we have noticed that when you look at these factors, it's plus or minus 6 among them, or probably is 6 one of the factors. When you look at these solutions, is 6 one of the factors or the roots, the actual roots?
No, it's not.
Yeah, so that's why I'm saying that it's always better to start with small ones. Because if we were to say we put 6 there, isn't it? X is equals to positive 6 there, right? So we have 6, you drop down, so it will be 6 times 1, it's 6. 6 minus 2 is negative, probably 1. Then 6 times negative 1, you have negative 6 there, right? So negative 6 minus negative 5. So you see that your figures will be going bigger and bigger, isn't it? But they can't give you a 0 there. You have gotten it, sir. But it's one of the possible.
Yes, I've got it. Thank you.
We proceed. So now we go to 19. Okay, question 19 is telling us that the remainder obtained when 2x to the power 3 plus x squared minus 6x plus 1 is divided by this polynomial is twice the remainder obtained when the same expression is divided by x minus 1. Find the value of a. So here our goal is we first use the same principle that we try to solve for a. So since, like, if you remember or recall, when we are solving for the values of a, we used to equate this guy here to 0, isn't it? So we first try to find the equation that will allow us to solve for k, right? So we say x plus 2 is equals to 0. That's where the negative 2 here is coming from. So when you substitute in this equation, where there's x, you put negative 2. We have negative 2 to the power 3 plus here it's negative 2 again, negative 2. Then you find that it will simplify to negative 16 plus a4 plus 12 plus 1, isn't it? So when you simplify this guy, if this guy is not equals to 0, then it's not a factor, but it is, you're using the remainder theorem. So 4a minus 3 is the remainder there. Now your next job is now you now use x minus 1. Now, hello? We have started with x plus 2. Look at your theory sheet, please. You started with x plus 2 to divide this polynomial here. So I want to find our second equation now. Since this guy has given us our first equation to be 4a minus 3, which is the remainder, right? Now, using x minus 1, we want to find the remainder as well of this guy. So when you use x minus 1, you substitute where there's x here, you put a 1. You discover that you have a minus 3 is the remainder. Now, our question here is telling us that when this polynomial is divided by x plus 2, the remainder is twice obtained when the same expression divided by x minus 1. So we say this remainder here is twice the remainder here, which is obtained when we divide x minus 1. So we say 4a minus 3 is equals to 2, which is twice. The 2 represents twice. The remainder is twice. Then you solve for a. Now, how do you solve for a? You multiply throughout by 2. You do the manipulation, play around with these guys. They'll give you a is equals to negative 3 over 2. Are we all okay there?
No, sir, I'm a bit.
So I bet you can come back, you can start again because me I didn't get it from the word go.
Okay, so here you have your question, right? Your theory sheet.
Yes, we do have.
Yeah, so here we're trying to use the remainder theorem, isn't it? Remember the remainder theorem?
Yes.
Yeah, so if you remember the remainder.
No.
Sir, please go back to the notes. I believe you did the remainder theorem.
No.
So we know that
No.
x
Yes, sir.
plus 2, we solve for x. We equate this guy equals to 0. So we know that to give us x is equal to negative 2.
0.
So now, for our first equation, we substitute where there's x, we put a negative 2. So we know that we have negative 2 to the power 3. This is here. We're just substituting. I hope it's clear there. Then when you substitute this guy here, so if you equate this guy,
yes,
we know that this guy, it will always give us a remainder. It is not a factor, isn't it? We're dealing with remainders now. So this guy can't be equals to 0. Are we okay?
yes, sir.
Yeah, so when you do the manipulations for this guy, it will be negative 2 to the power 3. It's negative 8. Negative 8 times 2 is a negative 16 you have in there. So now when you do negative 16 plus 12, it's the negative 3 which is there. And then 4 times a is the 4 here. This is the remainder of this function when we substitute this negative 2. So now, since we know that this guy is the remainder, right? So we use the second polynomial to divide into the same equation here. We solve for a again. So since we started with x plus 2, we can go with now, we can use x minus 1. So we solve for x when we equate to 0, we have x is equals to 1. So now when we substitute where there's x, we put a 1. You find that 2 times 1 is just 2. Then a times 1 is just a. Then minus 6, right? So 6 minus 6 plus 1 is just negative 5, right? Negative 5 plus 2, which is in front, is negative 3. So you have a minus 3 is the remainder again. And then they are saying that the remainder which is obtained is twice the remainder which is obtained when you divide this guy here. It's just that I don't have the questions at the moment. My phone has gone off. So here, I hope you're seeing the question. They're saying that the remainder that is obtained when you use this one on top, here x is twice the one obtained when you use x minus 1. So when you know that information, you say this remainder is equals to is twice the remainder which is obtained here. Then you just solve for a. Are we all together now?
So
you run through them. I think
Kindly
just
repeat.
I think just scared, guys. Can you just finish it? Here, if you have questions, you can get back to me.
The science were tired. No?
Yeah, that's what I was.
We're tired.
So for the rest of the questions, you finish them. If you have challenges, please call me back. I'll send the solutions.
Okay.
Yeah, and then
But don't forget.
Yeah, I think I won't do the correction.
Yes, I should just send the solutions.
Yeah, I'll send them. So For the corrections, you do them on your own. Since I won't have time at the moment to go through them, I'll just send them. Thank you, people. Have a blessed evening.
Thank you. Bye.
Okay, thank you for finishing our bundle.